Dear students, welcome to the fifth class of HVAC. In this class, I will be talking about different applications of HVAC like auditoriums, operation theaters, library, atrium of a shopping mall, and all this. First, let me try it auditoriums. I will draw the diagrams, see the diagram minutely, and then follow my lecture accordingly. I'm sorry, the camera focus was lost. I have again corrected it, so you can see now. First is auditorium, the second one is operation theatre in hospitals. These are particular applications of air conditioning I am going to show, which are typical air conditioning connections. These are not like comfort air conditioning. Now I am talking about the air conditioning of specific applications. Here the specific application is auditorium and operation theatre. You generally have air conditioning systems in airports, buildings, residential complexes, shopping malls, hotels, etc. These are generally same types of air conditioning everywhere. But there are air conditioning processes where same type of air conditionings are not there. In case of shopping malls, etc., it is coming through the false ceiling. The supply air is coming out through the diffuser, supplying downside. The return air is being taken back by the diffusers and grills, and it goes back to the HU. Again, it supplies to the supply system. Through the supply duct, it comes to the diffuser. Again, comes down. Again, goes back to the return air duct, goes to HU, and comes back, and the cycle continues. The cycle is same in these two cases, but the operations or the ducting layouts are different. What ducting layout you are making for general shopping malls, etc., is not going to work here. Here you are to have a separate ducting system for that. And that's what we are doing here. What we are doing, in this case, this is the theatre. This is an auditorium. This may be auditorium, this may be cinema hall. This can be a cinema hall also. Instead of auditorium, I can tell it is a cinema hall also. This can be written as cinema hall or auditorium. They are having the same structures. What is there? This is stage. This part, you are seeing this part. This is the stage. This is the sitting arrangement. In case of cinema halls, sometimes it happens the sitting arrangement, in case of this, the sitting arrangement here is like this, and then there is a balcony at the top. But approximately the same. In auditoriums, like our auditorium, A block auditorium we have, this is the sitting arrangement generally. This is the sitting arrangement. And you have to do air conditioning in auditorium. It's not an easy task. Auditorium is having a high height there. Here is a high height. Here is a decreasing height. You can see this, the height is different. In case of shopping malls, buildings, etc., the height is same. So here air conditioning will be so proper that the people gets maximum air conditioning or chilling effect. So you have to have a very specific type of air conditioning. Very specific type of air conditioning, as I am telling you. To do this specific type of air conditioning, in this case, we are having an HU placed at the below the stage. You have a stage where the action is going on, where speaker is giving the speech, or in case of cinema hall, there is a screen here. Below the stage, here HU is set. Air handling unit. Below the stage, there is a room actually. If you go to inside of the auditorium and inside of the cinema hall, you will see below the stage there is a room. That room is generally occupied by the HVAC engineers. Air handling unit is placed here. Here the air handling unit is placed. This is the blower of the air handling unit. Through the blower, it supplies air to the system. See, so neatly designed system. Here is the stage. The height is very high in the stage. So in this case, you are throwing air through the supply duct even at the vertical. Through the grills. Grills are provided here. Through the grills, this is the supply air duct. Okay, show the direction of the duct. This is the direction of airflow. This is the direction of airflow. This is supply direction of airflow. This is return direction of airflow. So in this case, through the grills, the air is being supplied to this arena, to the stage. People get chilled. Then it comes here and supplies air at different locations. Here the maximum height, but this is compensated by the minimum height here. So when you calculate the heat load, you generally take an average height somewhere here. That average height takes care of the lowest height and the highest height. You have to find out during heat load the tonnage and the CFM, that's cubic feet per minute of air supplied, and the tonnage of the room. In that case, you calculate it taking a height here, average height here. Now in this case, air is supplied, supply air is supplied. This is the here chilled water coil is there, as I explained in the last class. You have seen that that is I explained in my 4th class, and this is the 5th class going on. In the 5th class, you can see there is, in case of this, there is a 3-way valve and all the arrangements are already there. So that is taking care of the chilled water flow. Now I am talking about the air flow. Water flow is one part of that, and then the air flow. So chilled water flow is taking here, but I am talking of the air flow. So in case of air flow, the air is getting supplied here in this arrangement. Then air comes here, 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 here. And this is the sitting arrangement of the people. Here the people are sitting. So I am supplying here to the top of the false ceiling. Here actually, if it is a false ceiling, you are supplied through diffuser. Sometimes it happens, it cannot be shown in this drawing. It is supplied through side grills also. Means here is a wall. If you go to the cinema hall, here is the I am showing you this in front view. If you take a sectional view from that side, you will see in a cinema hall there is a wall on this side, there is a wall on that side. So what we are doing, through these walls ducts are run, and through the air is supplied to the grills. Here I am showing through the diffusers. In some cases it is supplied to the grills as well. I think the concept is clear to you. Here I am showing the air is being supplied to the diffuser, so in above the false ceiling. Now this air is coming here. This is the direction of airflow. This is the direction of airflow. This is the direction of airflow. This is direction of airflow. This is direction of air. Air is coming here, this way. You are having at your footstep, where you are sitting in the cinema hall, at the footstep there are small diffusers, return air diffusers. You have gone to cinema hall, but you have not taken care of them. Or there are small setups below the seat. Here is the chair, here is the chair, here is the chair, and below the seat there is a small setup of air. That setup means there is a small diffuser here below the seat. Either it comes through this grill or it comes through this below the seat. This return air is taken below this. This is whole structure. ये अंदर खोखला है यहाँ पे. This is inside. This is open. This below this, like this room, this is an open area. In that we are taking the return air. This is the return air coming from the below the seat and from the steps of the stair. From the steps of the stair, we are taking the return air, and return air is coming back to the engine. See how efficiently and intelligently this has been designed. That is the thing to be noted. How efficiently they have designed the system so that proper air distribution is there through the system. It's not easy to make a proper air distribution through the system. So the designing is such that the proper air gets distributed through the whole building. That here also people gets air at the behind rearest part of the building, and also at the front part of the building they get air. And also they get air in the stage who are working, like the speaker, like the, if rehearsal, some theatre is going on, the actors, if something else is going on here, for them this is required. In case of cinema hall, this portion won't be there, because here is a screen. There is nothing in that theatre part, in that stage part. Here is the screen, so this part can be emitted, but this part remains the same. In case of auditorium and theatre halls, this is generally designed. But in case of cinema halls or picture halls, this part is not required. Here the air goes, here is the screen, behind the screen it goes, and it goes out like that and supplies. So in this way, the auditorium air conditioning air system air layout system. This is actually called HVAC ducting layout. This HVAC ducting layout system is designed. How the air conditioning is done in auditorium. Try to understand everything. If you have any problem, please ask me through the chat box present in the Microsoft Teams. Ask me through the chat box any question you have on this. Then we have, this is in case of auditorium how we are doing. Then we have the second part, that is operation theatre. Now in case of operation theatre, we are having a supply air ducting system. This is the supply air ducting coming from HU. This supply air ducting is coming from HU. And this return air is going to HU. Don't be confused between these two. This is supply air. I have shown the direction of air. This is the direction of air. So this supply air. Here is the pendant. And there is a structure called laminar flow diffuser. I'll write it clearly so that you can understand. Laminar flow diffuser. This is the laminar flow diffuser, this one. This laminar flow diffuser, if you see the part of that from the top, this is actually a pendant. If anybody has gone to operation for any reason, or in an operation theatre, where surgical procedure is done, if you see at the top, you will see a pendant. Here is a lighting arrangement, a box-like arrangement, rectangular arrangement. In between there is a lighting arrangement, and lighting arrangement is covered on all the sides with laminar flow diffuser. What does laminar flow diffuser do? Laminar flow diffuser supplies the air in a laminar flow pattern. Laminar flow means layer-wise flow. There are two types of flow, you know. One you read in fluid mechanics, one is laminar flow, one is turbulent flow. Depending on the velocity, it is divided into laminar flow and it is divided into turbulent flow. So below a certain velocity, it remains the laminar flow. Here, that velocity is maintained at which it remains the laminar flow. That means a layer-wise flow. When layer-wise flow happens, what happens? You see, here is the operation theatre and here is the patient. Here is the patient. Here is the operation theatre, table, operation table. Here are the doctors and nurses on both the sides. And here the air is being supplied continuously. This is supply air coming through this side, through the doctors. They are passing through the doctors, patients and the nurses. The air is passing. So what is happening? They are doing a laminar flow diffuser, doing a sweeping action. Sweeping is jharu dena. It takes a sweeping action, takes all the dust particles from the body of the patient and doctor. What is the main source of infection in case of operation theatre? The doctors, nurses and the patient himself. Because many microbes, small viruses, bacteria, they enter along with the doctors and patients in through their dresses and their body in the system. And remember, when some portion is cut, and if that cut portion or surgery where it is done, that portion is infected by virus or bacteria, the patient may die because of septic and such things. You must have heard in case of many operations there happens to be septic and such surgical lapses or problems due to which the patient later dies. So it's very important that such things don't happen. In this case, the air is coming like this, air is doing a sweeping action, it sweeps through the patient, and as it sweeps through the patient, the dust particles go and it comes here and then goes to the return duct to the air and back again. It comes to the laminar flow diffuser here. The layer-wise diffuser is designed in such a way that it leaves the air or releases the air at a particular velocity which is below the boundary layer, below the boundary of the turbulent flow. That is laminar flow. Below a particular velocity, it sends the air so that it is a layer-wise flow, and the layer-wise flow passes through, sweeps through the sweeping action, takes the dust particles, and then through this return air. This is return air duct here at the bottom of the room. You can see at the bottom of the room there is a return air duct. At the bottom of the room in operation theatre, the return air duct, it takes back, this air is taken back to the air handling unit. So it is showing a total system where how a operation theatre works. I think the operation of the operation theatre is very clear to you. This is the way the operation theatre works. Air is coming from the air handling unit, coming through laminar flow diffuser, goes the layer wise flow, and then goes. Then one important thing which I have not mentioned here that I would like to mention, here is a small part here placed. This is called HEPA filter. HEPA filter. I mentioned earlier the HEPA filter. HEPA filters are the parts which sends the particles below 0.3 micron. Below 0.3 micron particles are sent to the HEPA filter. It takes out anything, any particulate matter above 0.3 micron will be stopped by this HEPA filter. That means it is an ultimate level of filtration. HEPA filters generally not used, very costly, and as you know, it is thrown away after few 1 month, maybe 1 month or 1.5 months. The HEPA filter is thrown away, new HEPA filter is brought here. It is not like that it is washed, cleaned and brought here. No, not like that. It is just thrown away and a new HEPA filter is brought here. It maintains the micron level below 0.3 micron. This is the level of accuracy it maintains in the operation theatre. Through this, the air comes through this return air, and this return air duct it is going through and passes again to the air handling unit. That means it supplies air through this like this, in a laminar flow happens and it returns to the supply return air duct to the system back again. This is how the operation theatre works, and this is how the auditorium works. I think this lecture is clear to you. These are particular and specific applications of air handling, air conditioning, which should be very clear to you. And I think it is clear to you. Thank you for attending the class. Any question, please ask me. You may ask me over phone also. You may ask me over chat box also in the Microsoft Teams. This is the video uploaded in Microsoft Teams and you can always see that. Thank you for attending the lecture.